Hello everyone. So in the previous lecture we have discussed about free body diagram, but today we will discuss about vector integration, that is the line integral, the surface integral and the volume integral. But to know more about this, that is to go through more about this, we need some basic things, that is the curvilinear coordinate, then the scale factors. These are the more important things, that the divergence, curl and the gradient. So we need this first thing, then we can go through this. So you have to read more about this gradient, divergence, curl, then you can solve this line integral, vector integral, or we will do another class for this divergence, curl and the gradient. So today we will discuss about the vector integration. So if you like the previous video, then please share it, then subscribe my channel and share it so that other students will be benefited. Okay, so let's start about the vector integration. So what are the important things we have to know? That the important things we have to know are the gradient. First of all, the gradient, and the gradient we can calculate for a scalar quantity. Then the divergence, and for a divergence we need a vector quantity, and for the curl we also need a vector quantity, but there is a cross product. So what is the gradient? The gradient is nothing but del by del x I cap plus del by del y j cap plus del by del z k cap, and we can write it in curvilinear coordinate system as your u cap by h1 and del by del u plus v cap by h2 into del by del v plus w cap by h3 into del by del w. So this is the gradient in a Cartesian, and this is the gradient. This is the gradient in curvilinear. Okay, so this is in curvilinear or polar coordinate. So these are two important things you have to know. Then what is h1, h2, h3? H1, h2, h3, these are all scale factors. These are all scale factors, and your u cap, v cap, w cap, these are the unit vectors. U cap, v cap and w cap, these are unit vectors, all unit vectors in curvilinear. Okay, so this is, you have to know basic things, that is these are the basic things to read more about the vector integration. So try to know about this, the gradient, divergence or curl, or if you don't know about this, then please comment in the comment section. We'll do another class to know about the gradient, divergence and curl. But today's chapter is vector integration. So generally basic things we want to know this, then we can solve the vector integration. So the scale factor h1, h2, h3 and UVW are the unit vectors and the curvilinear coordinate system. So what are the curvilinear coordinate system? The curvilinear coordinate systems are, so what are the curvilinear? So one is the cylindrical, then your spherical. I am not going to more about this. I just simply tell you what you want to do the vector integration. So the cylindrical, your h1 is 1, h2 is r, h3 is 1, and in cylindrical u is r, v is theta and your w is z. But in spherical, h1 is 1, h2 is r, h3 is r sin theta, and your u is r, v is theta and the w is pi. So the theta is 0 to theta pi, and your phi is 0 to phi 2 pi. Okay, so and this is the radius, so it is can be 0 to infinity. That's the radius. The radius can be 0 to infinity, but here in this case 0 to theta is your 2 pi. This is the cylindrical coordinate system and the spherical system. The scale factor and the unit vectors u, v, w in the curvilinear coordinate system. So if you don't know about this, then please comment. I will take another class to know about this scale factor and unit vector. Okay, so these are the simple things you have to remember: the scale factor and the. Then we can solve the vector integration. Okay, so vector integration. And remember, this is for higher secondary, that is the B.Sc level. So we cannot see these types in a CHS exam or your class 11 or 12. This can only be studied in your B.Sc level. So what are the vector integration? So we have three types of vector integration. That is, the first one is the linear or line integral. Then second one is your surface integral. Then third one is your volume integral. So these are three vector integral. So you have to remember the line integral, the surface integral, and the volume integral. Okay, so let's first solve this line integral. So to know this line integral, so what is the form of the line integral? The forms are, we can write is the line integral that a vector dot dl vector, or phi into dl vector, or a vector cross dl vector. So these are the three types of line integral. Okay, so these are the three types of line integral. So types of line integral. So these are the three types of line integral: a vector dot dl, phi dot dl, and a cross dot dl. Remember, a is a vector field, but phi is a scalar field. Okay, so a is a vector field and phi is a scalar field. Then what is the line integral? That means what is the line element? And the line element, what is the line element? So the line element is your dl, that is nothing but your dx I cap plus dy j cap plus dj k cap. So this is the line element, and this is the line element factor, that is the dl. So it is your dx I cap plus dy j cap plus dj k cap. Okay, so this is the line element, and suppose another vector, that is the a vector. So this is given to you, that is the a vector equal to a1 I cap plus a2 j cap plus a3 k cap. Suppose this is given to you, this is your a vector. Okay, so suppose this is given to you, that the a vector is a vector field. So a vector is your a1 I cap, a2 j cap, and a3 k cap. This is given to you. This is given to you. So what will be the a dot dl? That is the first one. So this is nothing but the integration of a1 dx plus a2 dy plus a3 dz, because this is the dot product with the dl vector and a vector, dl vector and a vector. So here a vector dot dl, do the dot product, that will be a1 dx plus a2 dy plus a3 dz. Okay, so this is the dot product, the dot product of the a vector with the dl vector. So we can write it as a dot dl equal to a1 dx plus a2 dy plus a3 dz. So simply we know the integral. So a1 dx plus a2 dy plus a3 dz. Okay, so this is the representation. We are doing the representation. We'll do more about the line integral. Now what is the phi dl? So your phi dl will be phi dx I cap plus j cap into phi dy plus k cap into phi dz. This is a scalar field. Phi is your scalar field. So the phi into dl. So what will be phi into dl? So this is the simple multiplication. So that will be phi dx I cap plus phi dy j cap plus phi dz k cap. Then just to do the integration, that will come in this way. So this is the your phi dl. Then a cross dl, you can calculate the a cross dl value using the cross product. That is, we have to find the a dl, a cross dl. So what is a cross dl? To do the cross product, that is a dl, sorry, a cross dl. So we have I cap, j cap, then k cap. Then what is the a component? A1, A2, A3. What is the dl component? This is dx, dy and dz. Then you can do the cross product and you will find that this is nothing but I cap into your A2 dz minus A3 dy I cap, then plus j cap into A3 dx minus A1 dz, then plus k cap into your A1 dy minus A2 dx. So you can do this as your cross product, the line integral with the your vector field. So this is the cross product. Simply you have to, given a vector will be given to you, and a dl vector is your dx I cap plus dy j cap plus dz k cap. So you can do the cross product and simply do the integration. So the important thing is how we will do the line integration. This is the important. So these are the representation, three types of representation. One did with dot product, then the scalar field, then with the cross product of with the vector field. So these are all the representation of the line integral. Then we will do how we will do this line integral. How to solve this line integral? So line integral, how we solve? Now we need a path. We need a path. Okay, we need a path or curve C. So we'll represent the path of the curve as C. So we need a curve on which we will do the line integral. That means, suppose a vector field is given to you, then a dot dl, we need a curve. So this is the line integral. Okay, so this is the line integral, and some curve will be given to you. That curve may be circle, that curve may be circle or parabola or ellipse or your linear curve, etc. Okay, so this is a curve path. That means found the line integral in the circle path, that is found the line integral in the parabolic or the ellipse or in the linear path. So to know this, to find out this line integral along a path, we need the parameterization. So this is the important. So these are the path. Then how you will parameterize it? Sometimes we can write this line integral as a dot dr also. A dot dr also. So that also give you a vector dot dr by dt into your dt. Okay, so this is also another type of vector, line integral, another form in terms of t. So we need the parameterization. That means, what is the parameterization we need for this curve C? So what is A? A is the starting point and B is the ending point. But we need this curve Okay, you can see the curve also, C also. So this is another formula. We can write the dl as dr, both are the line element, but in terms of time, that is dr by dt into dt. So we need this r, that means we need this path. So what is the parameterization? So this is another important. Okay, please check the, let's check the spelling. So this is so we need the parameterization. So what are the parameterization? Then we can calculate line integral. So we need the parameterization. So what is the, suppose a line is given, a linear, that is a line is given. So what is the line for? Y equal to mx plus c. M and c are constant that given to you. M and c are constant. So the m is your slope and c is your constant, that is depend upon the intercept. So if x will be t, then y will be mt plus c. So your path is, this is a two-dimensional path. Okay, so t, then mt plus c. So this is the path, because r vector, what is r vector? Now the path is r vector equal to xi cap plus yj cap. So we have taken let x equal to t. This implies your y will be mt plus c. So what is the path? Now x है t and y is your mt plus c. अगर हम x को t ले जाते हैं तो y कितना होगा ना mt plus c. और m और c तुम्हें दिया होगा, अगर नहीं दिया होगा तो एक लाइन दिया होगा. So it will be given a line and the 2 points will be given to you. That is the A1 B1 point and this is a 2 B2 point. Then you can find out using this parameterization. So this is the linear parameterization. How to you parameterize a line using this linear parameterization. Okay, so if 2 point also given to you, so this is one technique. And another parameterization is suppose 2 point is given to you, that is a 2 point parameterization. So 2 point if given to you, that is your point A1 and B1 and another point, this is the line path. Okay, this is the linear path. One point is A1 B1 and another point is your A2 B2. Then how you will parameterize this path? This is also a linear path. You can use y equal to mx plus c and x, take x equal to t, then y will be your mt plus c. But another thing, this actually this thing is easy. 2 point uses the parameterization, 2 point parameterization. So first of all, that parameterization will be your, okay, so the parameterization will be what? Now A1 B1, A1 B1, this is comma, plus t into A2 minus A1 and B2 minus B1. So remember, this is also another linear parameterization. If 2 point is given to you and the path is linear, remember the path should be linear, then we can apply this. Okay, if 2 point is given to you, that is A1 B1 and A2 B2 and the path is linear, then how you will parameterize it? Now your parameterization will be A1 B1 plus t into A2 minus A1 B2 minus B1. That means your x will be A1 plus t into A2 minus A1 and your y will be B1 plus t into B2 minus B1. And remember, here in this case 0 to t1. Okay, so this is the linear parameterization. Remember, this is the input. If a 2 point is given to you and the path is linear, then how will you use the parameterization? Now x equal to a1 plus t into a2 minus a1. What is a1 b1 a2 b2? Now these are the 2 points, that is one is starting point and another is the ending point. You put t equal to 0. If you will put t equal to 0, then what will be x? X will be a1. What will be y? Y will be b1 and a1 b1 is the starting point. Then put t equal to 1. if you will put t equal to 1, then x will be your a2 and y will be b2. So this is your endpoint. So these are the linear parameterization. We use this. Why we are studying this parameterization? Because using this parameterization we can solve the line integrals. Okay, so these are two line linear parameterization. Okay, remember the limit is important, 0 to t1. Why we are taking 0 to t, t is 0 to 1? Because when we will put t equal to 0, you will get the starting point, and when t equal to 1, you will get the ending point. Okay, so we are studying line integral, but in line integral we need the parameterization. Okay, so this is the parameterization. You can whatever we use the in parameterization, we can use t, we can use r, we can use theta, we can use phi. So these are all parameterization symbols that we can use in the linear path. We used t, but next to go to the parabolic path. If this is the parabolic path, then we know that parabolic y equal to x square or your x equal to y square. So these are the parabolic path. So if you take x equal to t, then y will be your t square. Okay, so these are the two paths, and in this parabolic path, if this is the starting point a1 b1 and then a2 b2, then the path is y equal to 4ax square, suppose given, and then take x equal to t, then y you will get 4a t square. So this is the parabolic path, but important is the linear path and then the circular path. So in the circular case, we know if it is a circle, so and the radius is r, then what will be the parameterization we did in the, if you will study the polar coordinate system, then your r will be what? Sorry, so let's take this is radius as a, so your path will be a cos t, then y equal to a sin t. Okay, so x equal to a cos t and y equal to a sin t, and we know x square plus y square equal to a square. Solve this, you will get a square. So what is the limit of t? So 0 to t 2 pi. So these are all the parameterization for the line integral. So you can solve this using the line integral. Then how we will solve the line integral? Suppose a vector, okay, your parameterization is over for the line integral. So now suppose this is given to a dot dr and the path is a circle, x square plus y square equal to 4. And your a vector suppose is given to you, this is a x y I cap, then y j cap. Okay, so this is 2 vector, 2D vector. This is a vector field given to you x y and y. Then remember what will be in the c path. What will be c path? Now r of t equal to x y. We know this. Then what is x? Now 2 cos t. What is y? Now 2 sin t. Then according to this, what will be your a vector? This is x into y, so 4 sin t cos t. Okay, so 4 sin t cos t. Then what is your y? This is 2 sin t. Okay, so we can write this here as a dot dr by dt into dt. So what is a? A is your 4 sin t into cos t, then your y term is your 2 sin t, then what is dr by dt? Your dr by dt, this is r, so you can find the dr by dt, that is the minus 2 sin t into 2 cos t. Okay, then do the dot product, then derivative with respect to time, and your limit is 0 to 2 pi. So this is the line integral form, how you will solve it. Then do the dot product, this is one vector, that is the a vector, and this is the velocity vector, that is your dr by dt into dt. Then you can take the limit 0 to 2 pi and then solve this, you will get the line integral. So using this path, so if there is linear path, that is the 2 point will be given to you, then take the point parameterization and solve this, you will get the line integral. Okay, we'll solve some problem in if time will be, we'll solve, or otherwise we will take another class to solve the line integral, then the surface integral, that we will solve some problems. But today you know how to solve this. So using this parameterization of the linear or the circle or the parabola or anything that will be given to you, use the parameterization, then solve the line integral. Okay, so another line integral, that is using the fundamental theorem. Using fundamental theorem, how you will solve the line integral. Now suppose a vector is given to you and a vector is the gradient of another vector. Okay, suppose a vector is a vector field which is the gradient of a scalar field. Suppose gradient field is your, suppose the scalar field is your xy square, then what will be del phi? So your del phi will be y square then under 2xy. Okay, so this is the gradient of phi, and I also told you how to find the gradient in faster way. And starting class, I told you then how to find the gradient. So suppose a is given to you, that is the y square and the 2xy, y square 2xy. Then what do we find? That a vector, that is the vector field, is the gradient of this scalar field. So I am discussing about such case, that if the vector field is the gradient of a scalar field, if a vector field is given to you and that vector field is the gradient of a scalar field, then how you will find the linear path? So how you will find a dot dr into a dot dr. So your a is del phi dot dr. So remember, the path, that is so this is the path. So you will find phi final minus phi initial, like your phi is given xy square. Okay, so use this example also. So my opinion is, so if a vector field is given to you and that vector field is the gradient of a scalar field, if a vector field is the gradient of a scalar field, if vector field given is a gradient of a scalar field, if the vector field is the gradient of a scalar field, then you can use this such case. So a dot dr equal to delta phi dr. Then what is the integral? Now phi final minus phi initial. Suppose the path is given a1 b1 point to a2 b2 point in 2D. Okay, in 3D, a1 b1 c1, a2 b2 c2 in 3D. So that phi will be a2 b2 minus phi upon a1 b1. Okay, so this is the fundamental theorem. अगर ये वेक्टर फील्ड अगर ग्रेडियंट होगा किसी स्केलर फील्ड का, अगर जो वेक्टर फील्ड तुमको दिया है वो एक स्केलर फील्ड का ग्रेडियंट है, तो उसका लाइन इंटीग्रल हम अगर एक पाथ दिया है तो कैसे निकालेंगे ना? फाई का जो फाइनल पॉइंट है उसको पुट करिए, फिर उसको सब्ट्रैक्ट कीजिए फाई का जो इनिशियल पॉइंट है. So suppose initial point a1 b1 and final point a2 b2, then your line integral will be phi of final point minus phi of initial point. So what is the phi of final point? This is a2 b2, so that will be a2 b2 square minus a1 b1 square. Using this example, okay, using this example, So that will be your final answer. So in this way you can use the fundamental theorem. If the curve is starting from one point to end at another point and the vector field is the gradient of a scalar field, then you can use this fundamental theorem to find out the line integral. Okay, we'll solve problem. So remember, the important thing is the vector field should be a gradient of a scalar field. Then you can find out this fundamental theorem. Now, if the path is closed, so the case is given that the vector field is the gradient of a scalar field. Okay, so vector field is the gradient of a scalar field and the path is closed. That means the path can be a rectangular, the path can be a circular, the path can be an ellipse. If the path is closed, remember, the path is closed, so it is started from one point and end also at the same point. In the ellipse also, it started from one point and end in the same point. So these are the closed path. If the path is closed, so for a closed path, how we will denote the line integral? Now give an integration, then use a circle in the middle, then write C. So C is closed. C is closed. So what is the mean of the C is closed? That is, starting point is same as end point. I told you. So how we will find this line integral along a closed path? If A is the gradient, that will be phi of final minus phi of initial point. P of initial point and phi of the final point. So your final point is your initial point, your start point is your end point. So the answer will be 0, because phi final equal to phi initial, because the point is same. Phi your actually start point equal to end point means A1 B1 will be your equal to A2 B2. Okay, so if A1 B1 A2 B2, then phi of A1 B1 is equal to phi of A2 B2. Okay, so what is the main thing? Now remember, for a closed path the line integral is 0. Note this, for a closed path line integral is 0. Remember, for a closed path line integral is 0. So this is important. So now we will do some application using this closed path. Now suppose two half circle is given to you. One half circle is this one. Sorry, one half circle is this one and another half circle is this one, having same radius. Okay, so this radius is also R, this radius also R, but this is the path is a B.Sc path and this path is C.D.A path. Okay, so these are two closed curves. So now you join this. So you join this, you will get A C. This is your B path and another is the D path. So these are two half circle. Now join them. Okay, you will get a complete circle. So you will get a complete circle. So what happened in the path C, capital C? So we know that A dot dl into C is 0 because the C path is closed. So this is the C path. Okay, so the C path is closed. This is capital C and it is a closed path. So the line integral is 0. We can break this closed path. How this closed path form? Now ABC A dot dl plus ABC, then CDA. Okay, and CDA. So this to sum is 0. This implies. So what is the closed path? Now a dot dl into closed path is 0 because the closed path line integral is 0. Then how this closed path form? Now the closed path is formed using the starting point a, b, c, then again c, d, a. Okay. So we can write this. So remember, this is c, d, a. So if you will change this path, so what is now c, d, a dot dl. So remember this. If you will change the path to a, d, c, then that will be one negative sign. Remember this. So if we change the path, one negative sign will be there. Okay, why negative sign? Because this plus will go to this sign, that will be negative sign. Then your ABC and ADC, that will be your opposite path. So the opposite path will give you a negative sign. So remember, your CDA equal to ADC. So if you change CDA to ADC, one negative sign will be there. So remember, these are the application of the closed path in the line integral. So remember this, using the line integral you have to read a closed path, and the line integral in a closed path is 0. The line integral in a closed path is 0. So these are all about the line integral. Then we will go to the surface